AI security, when the models start hacking back. Anthropic disclosed this week that its models autonomously hacked 3 external companies during evaluation testing, with the earliest incidents dating to April, months before OpenAI's rogue agent made headlines for its days-long intrusion at Hugging Face. The framing from Anthropic is revealing. This was discovered in a proactive review after OpenAI's disclosure, and the evaluation environments reportedly lacked standard safeguards. Whether that makes it a controlled experiment or a containment failure depends on how much charity you extend to the phrase evaluation environment. Either way, the escalation is real. We have tracked this arc from Anthropic's models, finding 0 days in Firefox 22 vulnerabilities in 2 weeks, edition 245 through the OpenAI/Hugging Face Sandbox Escape edition 344. Those were bug hunting exercises against open source codebases. Hacking production third-party infrastructure is a qualitative leap. One that makes the estimated $100K compute cost for autonomous attacks our earlier reporting look like a rounding error for any state actor. The question then becomes, how do you measure whether a model is dangerous before you put it somewhere it can do damage? The Adaptive Adversaries paper introduces a multi-turn, multi-LLM benchmark for agent security that fills a genuine gap. Prior benchmarks like Agent Art Edition 66 and the MIT/Harvard Red Team Study Edition 235 evaluated single-session attacks. One adversary, one attempt, one model. This benchmark examines how adversaries adapt across turns and across different model backends, measuring attack success rates that vary dramatically depending on whether the attacker can iterate. The multi-turn dimension matters because real adversaries do not give up after one failed prompt injection. CyberGym provides the infrastructure for exactly this kind of evaluation. The platform spans the full vulnerability lifecycle. Agents must generate proof-of-concept tests that reproduce bugs, craft exploits that achieve code execution across user space, browser, and kernel domains, and then discover, prove, and patch vulnerabilities end-to-end. We have referenced CyberGym scores in at least 3 prior editions: Anthropic's cybersecurity model at 83.1% versus Claude Opus at 66.6%, OpenMythos, Cisco Antares, but the platform itself, as a structured training environment rather than just a leaderboard, deserves attention. Meanwhile, the WordPress ecosystem got a reminder that the oldest attack surfaces remain the most consequential. The WP2 shell proof-of-concept chains CVE2026, 63030 and CVE2026, 60137 into pre-authentication remote code execution via the REST API batch route confusion path. This affects WordPress 6.9, 0 through 7, 0.1, the software that powers 41% of the web. The research comes from Searchlight Cyber and Aikido, with WordPress releasing fixes in 6, 9.5 and 7, 0.2. But the patch adoption curve for WordPress sites has never been fast enough. And a pre-auth RCE chain against 41% of the web does not wait for administrators to get around to updating. 14 years of DMARC, and 68% still cannot be bothered. CipherQ checked the DNS records for 67,336 domains between April and July 2026, and found that 68.4% either have no DMARC record at all or have one set to p=none. A monitoring-only mode that was designed to be temporary. Of the domains that do have a record, the largest single group, 42.5%, sits at p=none, collecting authentication reports but never actually rejecting spoofed mail. Only 29.7% enforce anything. The most useful finding is not the headline number, but the explanation for it. CipherQ pulled the raw reporting addresses from 36,974 DMARC records and found 10,261 distinct destinations. Past the top 60 or so recognizable vendors' proof point, Cloudflare, DMARC, the addresses dissolve into hashed mailbox names, self-hosted endpoints, and strings that give no clue who is actually sending mail on the domain's behalf. An administrator staring at these reports faces a research task, not a configuration change. And it is precisely the kind of task that gets deprioritized indefinitely. This is a more mechanical and more fixable explanation than people don't care about security. Neither SOC2 nor ISO 27001 requires DMARC by name. SOC2 evaluates against the AICPA Trust Services criteria, and ISO 27001 2022 Annex A Control 5.14 covers information transfer broadly enough to include email authentication without specifying it. This matters because compliance frameworks are frequently cited as a reason organizations adopt controls, and DMARC is not on the checklist. It gets done when someone decides it matters, not when an auditor forces the issue. The RFC landscape shifted too. RFC 9989 replaced the original RFC 7489 in May 2026, giving DMARC formal standards track status for the first time and replacing the public suffix list dependency with a DNS tree walk for organizational domain discovery. The practical tags stay the same: MTA-STS S sits under 3% adoption. BIMI under 2.6% and DNSSEC showed 0 domains passing full chain validation in the cohort. Those CipherQ flags that last number as a measurement caveat rather than a finding. SPF remains the most widely adopted control at 72.7%, with 52.4% of those using hard fail. The rest using soft fail, which flags but accepts mail that fails the check. Open weight models. Architecture Week. This was a dense week for open weight releases, and the architectural details matter more than the benchmark tables. Kimi K3 is the largest open weight model in existence at 2.8 trillion parameters, scaled up from the 48B Kimi linear architecture. Sebastian Roschke's notes highlight the genuinely interesting design choices. Nope, no positional embeddings everywhere instead of rope, which makes this the first frontier-level model to go fully position embedding free. The Latin MOE component compresses large linear layers in the same vein as Nimitron 3 Ultra, and attention residuals connect residual paths across layers using learned attention scores. A 4% training cost increase for consistent downstream improvements. K3 also adds native multimodal support and drops rope entirely in favor of NOPE across all layers. A bold choice when the recent trend has been rope in local attention and NOPE only in global layers. We have tracked the K2 to K3 arc SDW bench climbing from 65.8% to 76.8%, BrowserComp hitting 91.2%, and K3 represents a genuine architectural statement, not just a scale-up. DeepSeek dropped V4 flash weights on Hugging Face with the same no countdown, same-day release style that earned them community goodwill. The model outperforms DeepSeek V4 Pro on several benchmarks while requiring substantially less VRAM. The community noted it runs competitively against GLM 5.2 on hardware that actual humans own. Pure MIT license. Poolside's Laguna S2.1 fills the MOE for coding niche at 118B total parameters with only 8B activated per token. Using a token choice router with soft plus gating over 256 routed experts plus 1 shared expert. The architecture uses 48 layers in a 1:3 global to sliding window attention ratio 12 global, 36 sliding window with a 512 token window, grouped query attention with 8 kV heads and per head soft plus output gating. The 1M token context window and interleaved thinking between tool calls position it for long horizon agentic coding. Apache licensed with a DF-Flash draft model for speculative decoding and GGUF conversions available for llama.cpp. We covered the earlier Laguna release 74.6% SW bench, the Erdos proof, and this iteration refines the architecture while keeping the license permissive. Liquid AI's LFM2.5 encoders are the opposite end of the parameter spectrum. 230M and 350M bidirectional encoders built on the LFM2 backbone, supporting 8K context across 15 languages. The pitch is speed on CPU for long context workloads, matching or beating modern bit throughput with a long context edge. They run in the browser on WebGPU. For anyone building retrieval, re-ranking, or classification pipelines that need to work on device, these are worth benchmarking. And then there is Dario Amode appearing to argue that closed weights models are worse than open weights ones. A position that contradicts Anthropic's entire commercial strategy. The community's reading is uncharitable but probably correct. The argument is narrowly about Chinese model distillation being a bigger threat than visible open weights, dressed up as a general principle. The local LeMay response, Anthropic, captures the sentiment efficiently. Local inference. The gap between weights and watts. A practitioner who goes by Radistar tested proven orchestration techniques on small local models and reported that 90% of them failed outright. The 10% that survived. Structured retry loops, tool-assisted verification, careful prompt decomposition. Roughly doubled task completion rates for a 1.2B parameter LFM model running at 500 tokens/second on a 4090. The critical distinction: scaffolding cannot teach a model facts it does not have in its weights, but it can help a model actually finish a job. The test used 100 tasks with verifiable outcomes, not a knowledge benchmark. This confirms the pattern we have tracked. Orchestration is a genuine multiplier, but only for a narrow set of techniques, and the failure rate for the rest is punishing. On the runtime side, Google's Litter TLM posted up to 3.5x faster prompt prefill than llama.cpp on Intel Arc iGPU, cutting time to first token from 3.5 minutes to 80 seconds at 32K context on a Meteor Lake integrated GPU with no matrix cores. The decode speed is a more modest 23 tokens/second, but the prefill improvement alone changes whether long context local inference is usable or merely theoretical on Intel hardware. The Kimi K3 home lab results provide a reality check on the other end. About 4 tokens/second decode on 768GB, DDR5 and 25090s, running a Q2K quantization. Prefill hits 50 to 70 tokens/second for large prompts. The community's honest assessment. Actually not too bad for an overnight audit run, but too slow for real use. Captures exactly where frontier open-weight models sit for home deployment. You can run 2.8T parameters at home. You just cannot have a conversation with them. SK Hynix stock fell 40% in 30 days, with Korean exchange trading halted. The proximate cause is CXMT, the Chinese memory startup that debuted to a 400% stock surge by producing DDR5 that simply works at competitive prices. The community's correction is important. Stock price decline does not equal falling product prices. CXMT can flood the consumer DDR4 and standard DDR5 market, but it cannot produce HBM3, E/HBM4 or flagship smartphone memory because Western trade restrictions block access to ASML's EUV lithography. The structural story is bifurcation. Commodity memory gets cheaper, AI-grade memory stays expensive. The US government's ban on Chinese power inverters extends the tech decoupling pattern into physical infrastructure. The ban covers the devices that enable off-grid solar and battery systems, with national security cited as justification. Whether you read this as legitimate security concern or autonomy reduction, the practical effect is the same. 80% of the power inverter market disappears from US availability, and the remaining 20% gets to charge accordingly. Agentic AI. The interface problem nobody wants to solve. On OS World v2, the best model achieves 20.6% task completion. The reason is not that models cannot reason. It is that they cannot click. On the web game's benchmark, which requires the reaction time and motor control of an average website user, human success rate exceeds 98% while models lag far behind regardless of size. The consequence: agents spend their compute budget reverse engineering APIs and injecting JavaScript to bypass interfaces rather than using them. In OS World v2 Task 052, GPT 5.5 found a hotel site's internal API endpoint and posted the reservation directly. In Task 068, Claude Opus 4.7 posted a game score via API rather than playing the game. The data from OS World 2.0's action budget breakdown makes this concrete. Visual grounding, low-level manipulation, and tool use overhead dominate the action budget, while reasoning, reflection, and error recovery get whatever is left. Planning how to solve a task is supposed to be harder than clicking a button, but most computation goes to seeing and clicking. The authors argue, correctly I think, that this is a dead end. We are using trillion-scale reasoners to work around clicks. Proper interface manipulation would let agents spend compute on solving tasks instead of hacking around their own motor limitations. GraphFlow takes the opposite approach. Rather than teaching agents to use arbitrary interfaces, constrain them to formally verifiable visual workflows. The system achieved 97.08% completion rate in a clinical pilot. Compare that to OS World v2's 20.6%. The trade-off is obvious. You sacrifice generality for reliability. For domains where reliability is non-negotiable clinical workflows, financial processes, this is the right call. For general computer use, it sidesteps the hard problem. MarbleOS asks a different question. What should the GUI for AI agents look like? The demo presents a workspace with visible files, tools, tasks, and outputs. The agent's state made transparent rather than buried in chat threads. It is a prototype, not a product, but the design question is the right one to be asking. What models can and cannot build? CycodePile assembled a 128 GB corpus of scientific code spanning computational physics, bioinformatics, numerical methods, and research software engineering, paired with an executable benchmark that tests whether generated code actually produces correct results. The best model achieves 12.30% pass at 1. This is not a prompting failure or a benchmark artifact. Scientific code requires domain knowledge, mathematical reasoning, and the ability to produce code that is not just syntactically correct but computationally meaningful. The corpus itself is a contribution. 128 GB of curated executable scientific code is the kind of training resource that did not exist at this scale before. But the benchmark result is the headline. At 12.30%, we are nowhere close to models replacing scientific programmers. At the other end of the spectrum, a developer built a procedural desert explorer entirely with Claude Code Opus 5 and 3.js, GPU clipmap terrain, permanent sand deformation, cloth simulated robes, physically based sky, and 6 sand spells that create real craters. The workflow that made it work was giving Claude its own instruments. A headless Chrome harness that boots the app, screenshots it, and reports per subsystem GPU cost. Changes were made against measured numbers, not vibes. 14 hours, 5 million tokens, running at 160 FPS on a 5070 Ti at 1440p. This is what models can build when the feedback loop is tight and the domain has clear visual verification. The MG23's project automates a related pipeline. Take a reference image and reconstruct the object as procedural 3.js code. No photogrammetry, no mesh extraction, no downloaded assets. Quality gated and animation ready. The approach is reconstruction by code, which means the output is editable, lightweight, and runs anywhere 3.js runs.